at least a few stations on the next practical will be of the sheep brain specimens here. And similar to the brain plastic models, you want to make sure you understand what you're looking at from multiple different angles. Take, for example, there can be a specimen where you're looking at the brain from this angle, so basically a superior view. One from this angle where you're looking at it from an inferior view. One where it's a half a sheep brain from this angle, so a lateral view. And one where it's, say, a half a brain from this angle, so a medial, where it's sagittally sliced view. So we'll go through each of those different angles. But first off, what do you think it is you're seeing here? Exactly, you're seeing dura mater there, the thickest of the meninges right there. And when we take a whole brain, and I use the probe here to just barely lift it, there is a clear membrane, kind of as if it's been shrink wrapped. That's the pia mater. Notice how there's a clear membrane over the tip of the dissecting probe there? Sure enough, what I'm lifting there is the pia mater. All right, so there are those meninges that are visible here with the specimen. Let's pretend this was the practical, and there was a pin here that said name the space. Longitudinal, otherwise known as sagittal fissure. Name the space. Transverse fissure, good. What is this whole brain structure, all of this? Cerebrum, good. What would you say if I said name the lobe here?
Frontal lobe.
Here?
Parietal.
Here?
Occipital.
Here?
Temporal.
Good. What would you name any of the bumps on the surface of the cerebrum, like this?
Gyrus.
A gyrus, and anywhere there's a dark line, there's a blood vessel there corresponding to an indentation, good. A sulcus. What major brain region is this?
Cerebellum.
Cerebellum, good. Now, if I open the transverse fissure that we named before, and we look down in there, there's a pair of there's two pairs of bumps. A bigger pair sitting on top of a smaller pair.
Are those the hills?
That's the
Twins.
four twins. The top pair of bumps are the superior colliculi, and the bottom pair the inferior colliculi. So of course, if I stuck a pin into any of those four bumps, you name them individually. But what if I put a pin right in the middle of the four and just said name the brain region? What is the whole thing part of?
Midbrain.
The midbrain, good, exactly. So those four bumps you see are the pairs of superior and inferior colliculi when you open up the transverse fissure, but the whole brain region that you could name potentially for the whole thing is midbrain. All right, good. So that's pretty much everything I could ask you kind of from this angle. Lobes, fissures, the membranes, things like that. When we flip it over this way, we get a few more details. Take, for example, this is all brainstem here, and it's not so pronounced, but there's a bump right here. The pons, good. What is the next region of the brainstem after that?
Medulla oblongata.
Medulla oblongata. Then it really gets much thinner right here. Good, it becomes officially spinal cord. So it goes pons, then medulla oblongata, then finally spinal cord. It was cut, unfortunately, really short on this one, so I'm going to jump to this one. It's still wrapped in dura mater, but what do you think this is?
The X, the horns.
The X, the optic chiasma, the two optic nerves forming the X. Then they kind of messed up, something happened up here, so we'll jump back to this one. What do you think this, and this one got a little messed up, but what do you think this is? Olfactory bulb leading to this, the olfactory tract. Good. So those are the only cranial nerves I will ask you on the sheep brain. You have to know all 12 on plastic brain models, but only numbers 1, the olfactory bulb and tract, and the crisscrossing, structures here from the optic nerves forming the chiasma are all I'd ask on the sheep brain for cranial nerves. There's 12 of them to know, but only the first 2 do I ask on the sheep brain. The rest are also small. Like there's these tiny little cranial nerves like right here, and they're just not worth asking, in my opinion, on a brain they're so small and dried out. All right, so that's everything from this angle. The next way to ask structures could be seen from a lateral view, but that's a lot of things we've kind of already seen. So temporal lobe, frontal lobe, now seen from a different perspective. The fissure and cerebellum just seen from a different perspective. So things we've already talked about, but there could be a piece sitting this way and it's still knowing those same structures. But we get more detail when we flip to this side. take, for example, now that we have sliced this brain region that you correctly earlier identified as the cerebellum, I could now put a pin, say, here, and you now would name what? Arbor vitae, exactly, yes, good.
Arbor vitae.
Yep, good.
I think that's it. That's
Sorry.
that hidden arbor vitae that you said.
Yes, we'll get to those, yes, yeah, good. Now, notice how that was white matter. You can clearly see the difference between outer gray and inner white matter. And because they went a little off-center with their slice here, you can actually see the difference between, say, gray matter here and lighter white matter here. Now, it wasn't perfectly dissected. It's a little better on this side. And you can see, again, gray matter and white matter distinctions, right? Darker gray, lighter white. Notice the specific shape of the white matter forming a curve here. Corpus callosum, right? The white matter that connects right to left hemispheres, that curving white matter right there. And watch this. Notice how much of the probe just disappeared. Where did it go?
The hidden space.
The lateral ventricle, right? We said there are the chambers that enclose CSF, one of which never crosses the midline, but there used to be a membrane right there that we puncture through, and sure enough, we're down into the lateral ventricle. And of course, we can similarly see it on this half, so yes, they are paired. So sure enough, right where you find that corpus callosum, it leads into a space there, the lateral ventricle. Okay, now.
Could you tell it on the other side, in the front part, on this one? Remember how you showed us on the slide?
Yeah, like the fourth ventricle, we're going to see that in a second. Yeah, that's there. Yeah, they're all here. The thing is, I wanted to also see other structures around here. For example, note the distinct round shape here. What is the round structure at the very top of the brainstem? Not part of the brainstem, but what sits on the brainstem. The diencephalon sits there, and what's the round piece of it? The thalamus, yes. So this round structure here is the thalamus, which means if that's the thalamus, what must this region be? Hypothalamus. It is not a clear distinction. If there's a pin smack in the middle of the round structure, it must be thalamus. But if it's kind of well far down from the middle of that round structure, it must be referring to the region of tissue that is now the hypothalamus. Notice there is a space hugging around the thalamus. What ventricle is partially enclosed by the thalamus? Third ventricle, exactly right. So when you see a space off-center going near the corpus callosum, that is the lateral ventricle. But when there's a space hugging right around the thalamus, third ventricle. There's another space way down here in between the cerebellum and the spine and the brainstem, fourth ventricle. And then look at this.
The central canal of the...
Yes, you even see some central canal of the spinal cord, the hole that goes right in the middle. And I bet, sure enough, if we were to look at one as a whole, you can find that, yes, there is a space going right down the middle of it, central canal of the spinal cord. Good. Now,
Looks like chicken.
tastes like it too.
I don't want to know that.
No. Okay, none of these have the pineal gland intact, and that one is not a common thing for me to ask anyway, because it's rare that it is intact. But where there was thalamus and hypothalamus, you sometimes find a little round gland sitting right back here. That's the pineal gland. Neither of these halves have it intact. Maybe come review day, as we get closer, we'll see if one has it better. But that's it for those.
What about the pituitary
Yeah,
gland?
isn't that the hanging right there at the bottom?
By your thumb?
What, here?
No, up.
Here?
Yeah.
That's the optic chiasma, just seen from a different angle.
Okay.
What do you think this is?
Fat. That's
It is fat, but what do you think it would connect to?
to the muscle, the...
Temporal.
This is the fat at the back of the eye. You can see how this is still connected to a piece of optic nerve right there. So actually, we do sheep eye dissection in A&P 2. They basically cut here, put it in one bucket, and put this in the other bucket, so it's like sheep heart. I keep saying that because I do sheep hearts all the time too in A&P 2. Sheep brain in one bucket, snip, put the eye in the other bucket, now you've got two different dissections to do.
Nice.
Yeah, it's a twofer. All right, so I'm pretty sure that's all the details from this angle. So from this angle, again, it's the white matter structures, like here, arbor vitae, and this white matter structure here, corpus callosum, and then all the spaces, lateral ventricle, third ventricle, fourth ventricle, and the central canal of the spinal cord. Good. All right, that's it for sheep brain.